Um, all right, so we're going to do the panic model that we had not done yesterday for the examples on, I think, page 3 or something. So the example of a two proportion test that you did yesterday that we did was the quitting smoking and wondering if the counseling group actually makes you more likely to quit smoking. Okay, and everybody's wearing the patch. So, um, what we did yesterday was we did the complete phantoms test. What was our decision yesterday when we did our phantoms model? Do you recall? So we ended up rejecting. Okay, good. So our decision, because I'm going to tie it into this, I'm going to tie it into the interval in just a minute. So we rejected the null. So did we find evidence yesterday that there was a significantly higher rate amongst those people who went to counseling? Okay. So now, you do not have to write all of this out on page 5. This is a continuation of a problem. If I ever ask you to do a continuation of a problem and now do the interval for it instead of the test, then you can just write same. I do not want to force you to do that. I wrote it here just so we know what we're talking about and we can revisit. So my P of S is that proportion of patch using smokers who do attend the support group and they are successfully quit smoking. And then P of N is the proportion of patch wearing smokers who do not attend the support group and they then quit smoking. So our numbers were as such. Okay. And again, if you have the same problem, you do not need to rewrite the parameters and conditions again. So let's go on to what this is now that we're going to be doing it. The name of what we are doing. What was the name of what we did yesterday? Two proportions, and it was a z-test. Two proportion z-test. So guess what this is going to be called? A two proportion z-interval. Very good. So that is the name of it. So now we know 4 things. One proportion, test and interval. One proportion z-test and z-interval. And two proportion z-test and z-interval. Okay. And guess what? Just like yesterday, how I introduced the calculator process to you, we get to do the calculator for two proportion ones as well. So that is something that I will always do for you this year, is I will always require that when we just have one sample, we do those by hand, even though the calculator can do them for you. I want you to do that because it maintains your understanding of how to find the z-scores and the p-value and all that kind of stuff. But because the two proportion kind of gets dicey, then we're going to do this, I'll let you do it in the calculator. The catch is you have to tell me which way you are going to subtract. So which way would you like to subtract to find the difference between these two things? Which way? Pick a way, doesn't it? We'll do P of S minus P of N. All right, there we go. So to do this, you must always define which way you subtract so that we can then make a correct conclusion. So we will define that I'm going to subtract the support group proportion minus the no support group proportion. So go to your calculator now, and we're going to compute this. And do you remember yesterday where we learned to go? Stat over to test. Stat over to test. And let's peruse what we got going on here. I see number 6. That's what you used yesterday. Two proportion z-test. Let's keep going. What do you think it is? Ding, 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 ding. Two proportion z-interval. In my menu, it was the B. So I'm going to hit enter. Okay. And then my numbers, I need to put in, recall from yesterday that, remember there on the on their homework, when you did the Tyson question, remember, I'm just going to review you real quick. If you ever come up to a problem where they tell you the percent and it's 33% of 75. Remember that you had to turn this into a whole number, okay? Because you cannot have a part of something, okay? All right, but that was just a review of a calculator problem that you could have on your first homework one. So this one, how many successes did we have again for this, the 46? Okay, good. Our numbers were 46 out of 143. So we've got our 46 successfully quit out of 143. So that's my first one. So that's my P of S. And so then we've got to do the next one, which the next one was 30 out of 151. And so there are our numbers there. And I believe it asked us to be 95% confident. Look at how this just asks you, what confidence level do you want to do? You don't have to compute any stars or anything like that. Oh my gosh, that's so exciting. So we hit enter, and we get our number, 0.023. So 2 significant digits minimum. So 0.0, actually, if you think about it, let's do 3 so we can have a decimal in our percent. 0.0234, 0.223. Okay, so 0.0234, 0.223. Okay, and of course, you know, you can be thinking in your brain, this means 2.34%. And this one means 22.3%. Okay. All right. So then we're going to write our regular interval statement. So in this section, we're going to write our interval because I'm going to save this right here for something else. When we have two proportions, I'm going to save the conclusion for something else. We're going to actually write the conclusion we used to do. And what conclusion did we used to do when we had an interval? That's the way it starts. Very good. So I am 95% confident that the, and what is this problem of when you have two proportions, it's not, what is it about? The difference between them. So I'm 95% confident that the true difference between the, I could say, how about if I did it, the true difference in the smoking rate, or the quit smoking success rate. The true difference in the quitting smoking success rate, okay, is between 2.34% and 22.36%. And this isn't the finished. We're about to have something very important that I'm going to really stress to you that we need to have. Okay. So at this point, I need to know which one is higher or lower. I typically just always think which one is higher. So as far as which one had a higher success rate. If these numbers are positive, then which of the two proportions is the larger one? The P of S. Okay, so I'm going to say that again. If these numbers are positive, then I know the larger one is the first proportion that I subtracted with. So I'm going to say I am 95% confident that the true difference in quitting smoking success rate is between 2.34% and 22.36%. Higher for the support group. So that has to be there. That has to be there, because otherwise you are not telling me a good conclusion about which one is better and so on and so forth. So that must be there. Now, I want to just flip that and let's say what happens, so that you are aware of this. What happens if I had this? Suppose I had P of S minus P of N, and it came out to be negative numbers. Negative 0.223, it would have done this, to negative 0.0234. Do you see the interval? Do you see why it gives me, why does it give me, which one of those is smaller? Yeah, this left one is smaller, and then to the top one is bigger because they're negative numbers, okay, thinking of the number line. But here's the thing. When I would write my conclusion for this, I am 95% confident that the true difference in the success rate is between, okay? Now, how would it make sense to write this number that I'm about to write if I wrote it in percentages? Would it make sense to say to somebody, hey, guess what? Negative 22.3%. You can tell somebody negative 22.3%? No, you are not. And that is why you have a brain and you are a human to convert this context correctly. So I would still say between 2.34% and 22.3%, but how does it become different if these were negative numbers in the interval? Yes, you could say then lower for P of S. Okay? So lower for the support group. So that makes sense, that if I have positive numbers, then the first proportion is higher. And if I have negative numbers, then the first proportion is lower. All right, good? Yes, sir. Oh, man, that is a good question. Do you ever get one that's positive and one that's negative? And you do, and that's another thing we're going to talk about in a minute. You are just like ahead of me there. Okay, good question. Do you ever get one that's positive and one that's negative? And yes, we will talk about that shortly. First, we're going to go ahead and finish out the conclusion here. So we interpreted our interval. I'm 95% confident, blah, 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 higher for the support group. So what would have happened? That actually just ties perfectly into my next idea. What would happen if I had one that was negative? Okay, I'm just going to make these numbers up now. Let's say, and one that is positive. Okay, what if that was happening? What does that mean? That this one could be what? The support group could be lower, or it could be higher. Yes. So I'm such and such confident that so here's how we would do this. I am such and such % confident that the success rate is between 5.43% lower for support group up to 4.36% higher for the support group. Okay, so let's stop and process that. Good. So we're always just talking about that first one that we subtracted. And if it's a negative, then the first one is lower. Up to, if it's positive, then the first one is higher. Okay. Now, what is important about the fact that it goes from a negative to a positive? There's something really important in there going on. What could the difference be if it's going from a negative to a positive. The difference could also be, yeah, I would fail to reject HO. Nice. And I would be failing to reject HO because there's what inside the interval? Any ideas? Not the p-value. There's something special in the middle that represents no difference. So don't blurt it out yet. I want you to think in your mind. What is something in the middle of this interval? It's not exactly in the middle. It's not exactly in the middle, okay, but just it represents no difference. All right, so what did you come up with that could mean no difference? What's in there? Ah, very good. That's the magic number. A difference of 0 means they could be the same. There could be no difference. Hence, whenever we have difference problems, we have to address if 0 is in the interval, and that's what the last sentence will be. Is 0 in this interval? So that's what our final conclusion will be about. So let's reference our original problem here. It went from 2.34% and 22.3%. So does it contain 0? No, it does not. So then I say, since 0 is not in the interval, since 0 is not in the interval, this suggests that there really is a significant difference. Not just a little difference, significant, but a big difference between P of S and P of N. That's really as involved as we get in this class. So I've kind of taken you to the depths of the conclusions that we have to make from our differences here. So since 0 is not in the interval, this suggests that there really is a significant difference. So what type of sentence might we say if there is a 0 in there? We could say, since 0 is in the interval, then what do you think we could say? 0 is in the interval. There may be. Can I say there absolutely is definitely no difference? No. There may be no difference between P of S and P of N. Okay, very good. So let's make a connection here from the test to the interval. You remember you said that yesterday's result was to reject HO? Well, guess what our interval did? It was completely above 0. Our interval was completely above 0, and we had evidence to suggest that there really is a difference. So those should go together. You should think that that is jiving, that, you know, if we are rejecting HO, okay, then what does that kind of mean about our interval? 0 is in the interval or not in the interval? Not in the interval. Very good. Okay, what about this situation here? What if we had 0 in the interval? So if 0 is in the interval, what do you think probably would have happened upon running a test? What would we say? Yeah, if we fail to reject HO, that means we didn't have evidence. So that would jive with 0 is in the interval. Okay? So get those two connections straight. Again, Rejecting the interval, 0 is not in it. Failing to reject it, 0 would be in the interval. Okay, so then your assignment is to do the 2 panic problems on yesterday's homework. So the 2 panic problems, one of them is on page 8 and one of them is on page 10. Okay, so you're going to do page 8 and page 10. And then let's talk about something else, because I have it slated to take a quiz next class. So let's talk about that. So page 10, 8 and 10 for good, and then let's go ahead and do 11A, the first warm-up as well. I don't know. I wanted you to do 11A. Okay, let's just do that, 11A, and then we'll do 11B and C on the next class, okay, right before you take that quiz. All right, so let's go ahead and have you guys finish that for homework.